All right, welcome to the last section here of Chapter 11. This is Section 11.5, which is choosing a data display. It's very short and sweet to the point. And a lot of it is just looking at it as a whole and deciding, is it good data, is it not good data, and what should we use to represent it. We're going to tell whether each of the following, A, B, C, and D, are qualitative or quantitative, okay? Before we can do that, though, I need to tell you what these things mean. So, qualitative data consists of labels or non-numerical values, okay? And I'll show you an example of these in just a second. Quantitative data consists of numbers that represent counts or measurements. Okay? So it's basically quality or quantity, you've heard of that. So the easiest way for me to explain this further is just to do these examples. So the prices of used car. Okay, prices. We have to basically decide, is it a label or a non-numeric value, or is it a count or a measurement of something? And a price is a measurement, right? And so this would be quantitative. Okay. Jersey numbers, though. Okay, so jersey numbers on a basketball team. Your jersey number does not necessarily give you a value, right? You might have a like a jersey number that you like better, but jersey number themselves are meant to label people, okay? So this would be qualitative data. So it's important to note that just because numbers might be involved does not mean that it's automatically quantitative, okay? Lengths of songs. Well, the length of a song can be measured, okay? So that's quantitative. And the last one here, zodiac signs. Well, there's absolutely no numbers in there, so that's obviously qualitative. Okay? So basically, if you can count or if you can measure it, it's quantitative. If you can't, if it's just a label or it has nothing to do with numbers whatsoever, it is qualitative. So, pretty simple. Moving on. Analyze the data and tell whether it would be good to use a circle or a pie graph or a box and whisker plot. Okay. So let's look at A. A talks about the color of eyes and the number of people that have them. Okay. Whenever you're given data where only one of them has a numerical value, automatically box and whisker plots don't work. Okay. Remember, box and whisker plots are talking about numbers, like counting things, right? So in a situation like this, a lot of you might say bar graph. Well, we don't really draw bar graphs anymore. So we're going to use a circle graph or a pie graph for this one. Okay. On B, we're talking about speeds of vehicles. Okay. So we have interstate A and interstate B. Well, it'd be really, a circle graph wouldn't make sense here. Okay. This one would be where we use a box and whisker plot. Okay. Go with your gut. Go with your gut. If it looks like something that we've seen in class where we've made box and whisker plots, the answer is box and whisker plot. If it's not, then it's not. Okay, do not overthink this at all. Okay. The last thing here that we need to talk about in our notes is misleading graphs. Okay, so sometimes, like, I am so for real, on when you see some graphs on the TV, for instance, some of them are very, very misleading. Some of them are not, okay? But some of them are very misleading because that news organization or that, whoever is doing this wants to look better. And so they make this graph and they make it look like way different than what it should, okay? And so we're going to talk about certain graphs like that. So let's look at this. It's talking about tuition, room, and board at all college universities. And it gives you years that we talked about them. And you see it, we started around 16,700 and then we've gone up from there. But the problem here is we didn't start at zero. Okay. So it looks like, we started with like, oh, it's not that much money in 2008, but it's a lot of money there. Okay. But think about it. You went from 16,700 to like a little over 18, it really only grew about $1,000, which is not a lot, honestly. I mean, it is a lot of money, but it's not a lot of money when you're talking about, inflation and growth. So, the problem with this graph, the reason why it's misleading, is that it didn't start at 0. Okay, that's important for us to know. B, mean hourly wage for employees at a fast food restaurant. Okay, so this one does start at 0, and there is a break in the graph. So that's really, really, really good. And you can see that this graph makes it appear as though the minimum wage has gone up a whole lot, right? From 2008 to 2013. Look at that. Man, we have just done, no, you have not, because look at this. Okay, you started at $8.90. You ended at $9.05. You only grew 15 cents for the minimum wage. So the problem with this graph here is that we're counting by small amounts, and not only are we counting by small amounts, you are also inconsistent, because look at this. I don't know if you guys looked at this. You probably didn't, because I didn't talk about it. You went from 890 to 892. Okay, so we're counting by twos. Awesome. But then we jumped to 894, which is okay, and then 896, and then 898, and then 9, and then all of a sudden we've decided, okay, now we're going to only start counting by ones. Yeah, you can't do that, okay? So we're counting by small increments, and we're inconsistent, okay? And so that basically makes our graph look like it's growing more than it should, okay? We're going to look at some more real-life examples. I actually went to news organizations and found misleading graphs, and so that's what we're going to spend some time in class looking at. So that is officially your last notes section. Congratulations, you made it. Come with your questions to class, and I can't wait to see you.